All right, here's a short video on dividing decimals. So we're going to start out with dividing by a whole number because we can then do this division very similar to what we've been doing when dividing whole numbers. So we're going to see how that works. So we're going to take 2, divide that into 10.2. So 2 is our divisor, 10.2 is our dividend, and we're trying to figure out the quotient. So the first thing we do is we take up the decimal point, and that comes up above the line. So it's in the right spot. So we maintain that place value. And so we figure out 2 goes into 10 5 times. We subtract. That is 0, and then bring down the 2. Right? 2 goes into 2 1 time, and we have no remainder. So that quotient is 5.1. So it works essentially the same as we did for whole numbers, except you just have to remember to move up that decimal point. So let's change it up a little bit and try a slightly different problem. I'm going to do 10.2 or 10 2/10 divided by 3/10. Okay, but before I take a look at that and show you how to do that, let's convert this to fractions. Okay, so 10 2/10, so 10 2/10 divided by 3/10. Oop, that's not a 10. Let's change that 3. Should be a 10. I was already moving ahead to the 3. All right, so if we convert that to an improper fraction, we've got 10 times 10 is 100, 102 divided by 10 divided by 3/10. And essentially, we know now that if we have the same denominator, we just divide the numerators, right? 102 divided by 3, and whatever that comes out to be, right? If we do that division. Excuse me. Or another way we can take a look at this is by converting the division into a fraction, right? These are equivalent statements. So now this is a little tricky, right? We really haven't worked with any fractions that have decimals in them. Our fractions are all integer over integer. Or if we try to model the problem that we just did, it would be really nice if that 0.3 was an actual 3. So if that's the case, I can do my division like I normally do, right? So how do I make 0.3 into 3? Well, I multiply by 10. But in order to maintain an equivalent fraction, we also have to multiply the numerator. So we end up with 102 divided by 3. The same thing we had up there, right? Now, what does that look like when we take it to the division algorithm, right? If we start that out, if we just set it up the way we normally would, 0.3 divided into 10.2, and again, we don't like that. We can do it that way, but we're much more comfortable working with that as a whole number. So if I want to change 0.3 to a whole number, well, I have to multiply it by 10. I have to multiply it by 10, just like I did down there. But again, I can't just multiply that. Now I've changed what I'm dividing by, right? So in order to compensate, in order to make sure it's an equivalent division problem, I also have to multiply the numerator by 10, which means I have to multiply the dividend by 10, right? So if I'm going to multiply the divisor by 10, I also have to multiply the dividend by 10. And so that's how we get to the algorithm that if the divisor is not a whole number, we multiply or move the decimal point to the number of places we need in order to get a whole number. But then we also have to do the same with the dividend. So I'm going to attach some zeros onto the end there because it looks like this is going to be a repeating decimal. But let's see. So 3 goes into 10 3 times. We bring the 2 down. 3 goes into 12 4 times. So in fact, it's not. So we don't need those extra zeros. And 0. So 10.2 divided by 0.3 is in fact 34. So we have some context now of why the algorithm, when we do that division, if you move the decimal point over for the divisor, you also have to move that decimal point for the dividend. So let's take it one more problem. Okay, so we'll try this version of a problem. And here we've got 7/10 divided by 2 and 5/10. So we're going to change it to make it a fraction. And ideally, again, we don't like decimals inside a fraction, so how do I change that? How do I get an equivalent fraction without decimals? Well, 2.5, I'd like to be 25. So I'm going to multiply that by 10. And if I multiply the denominator by 10, I also have to multiply the numerator by 10. So that equivalently basically moves the decimal one place in each case. So 7 out of 25. Well, I'd like to write my answer as a decimal since that's the original problem. And so let's see, I'd like to be able to write this as something like over 10, 100, 1,000. Well, I can get from 25 to 100 by multiplying by 4, right? And remember, the only way to get an equivalent fraction is to multiply, not add, not subtract, but multiply or divide. So 25 times 4 is 100, and 7 times 4 is 28. So 28 100ths is 20.28, okay? 28 100ths. So if I did this in the traditional sort of format, 2.5 divided into 0.7, first thing we would do is we would move the decimal point one place in the 2.5. So equivalently, I'd have to do that. That's the same as doing this, right? Multiplying both the numerator and denominator by 10. So when I do that, my new decimal point is there. And I'm going to backfill some zeros because clearly 7 is smaller than 25, so my answer is going to be less than 1. So I have to move my decimal point up. So 25 goes into 7 0 times. 25 goes into 70 2 times, which is 50. So 20 and bring down the 0. 25 goes into 200 8 times. And so my answer is 0.28 or 28 100ths, which is the exact same answer I got before. So that is the motivation, and that's the reasoning behind this algorithm of, oh, when the divisor is a decimal, just move it however many places you need to get a whole number, but then you also have to do that in the dividend. Because, like I said, that's exactly the same as getting an equivalent fraction like we did before.